We recall that sine theta is defined as the y coordinate of the point on the unit circle. And notice when, and also we measure the angle with respect to the positive x-axis. So positive x-axis, this is theta equal to 0, and sine is the y value, which means sine 0 is 0. And as theta increases from 0 to this value, pi over 2, it attains the maximum value of 1. So sine 0 is 0, and then it's the height or the y coordinate is increasing, and it goes up to 1 for pi over 2. So let's plot the graph on the theta axis, and this time we want to split into pi over 2 and then maybe pi, and let's go in multiples of pi over 2. So 3 pi over 2 and 2 pi. So notice that as theta goes from 0, sine 0 is 0. So origin, and this is the value of y. Sine 0 is 0, and when sine, let's say this is 1. Sine is increasing when theta goes from 0 to pi over 2. So it goes up and then attains the maximum at maximum value of 1. And after pi over 2, now the heights are getting smaller and smaller, and it becomes 0 again at theta equals pi. So that's what you will notice in the graph. It's going to become maximum of 1 at pi over 2, and then it becomes 0 at pi. So this is the value, this is the point pi over 2 comma 1. And after pi, what happens is the y value gets more and more negative until it reaches this point, 3 pi over 2. And this is 0, negative 1. So sine of 3 pi over 2 is negative 1. So 1, positive 1 is up there, negative 1 is down here, and that's what we notice. It goes and takes the value of negative 1. And after it crosses 3 pi over 2, the y values are still negative, but they are getting less and less negative until it reaches 0 again at, so that would be 2 pi. So this is the graph. Now this graph actually continues. Theta is not restricted to just 0 to 2 pi. We can talk about going further than 2 pi. And what we notice is this piece continues to repeat itself because the y values, they repeat after every 2 pi. And also we could go in the clockwise direction. Then we can talk about these angles, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, and so on. And you can see that this pattern would continue on the negative side as well. So this is what you're going to see. So that's the graph of sine function. And so this is the graph of So let me write down f of theta equals sine theta. Now for cos theta though, what happens is, let's actually draw in the same graph, and I'll use a different color. So for cos, cos is the x coordinate. It starts highest, and then as you move, as theta increases, notice that the x coordinate keeps on getting smaller and smaller. X coordinate is this length. And eventually it reaches 0 when theta is pi over 2. So cos starts at 1 and then goes down to 0 at pi over 2. And the same behavior repeats. So what you will notice is that it's the same graph, but it has been shifted. So that's the graph of cosine theta. And let's f of theta equals cosine theta is the red graph, and f of theta equals sine theta is the blue graph. So a few things to notice. The domain for both sine and cosine is everything. So the domain for both of them is negative infinity to infinity, and the range is from negative 1 to positive 1, closed interval. Range is the y values. Domain is the x input values. You can input anything into sine and cosine. You're saying domain is negative infinity to infinity, but the answers you get, they can never go beyond positive 1, or they can never go below negative 1. And you can see it's because those are the coordinates on the unit circle. The unit circle has a maximum coordinate of positive 1. It does not go above positive 1. And the minimum coordinate of negative 1. It does not go below negative 1, whether it's x coordinate or y coordinate. Your x coordinate also cannot go beyond positive 1, and it cannot go to the left of negative 1 either. So that's the domain and range of sine and cosine functions, and that's the graph. The thing to remember about sine function is it starts at the origin, and cosine function starts at this point, which is 0 comma 1. It has a y-intercept of 1.